ಹಲೋ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸೆಕೆಂಡ್ ಪಿ ಯು ಓದ್ತಕ್ಕಂಥ ಎಲ್ಲ ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸಿಗೆ ಎಕ್ಸಾಮ್ಸ್ ಹತ್ರ ಬರ್ತಾ ಇದೆ. ಮಾಡೆಲ್ ಪೇಪರ್ಸ್ ಈ ವರ್ಷ ಸ್ವಲ್ಪ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಚೇಂಜ್ ಆಗಿದೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ನ್ಯೂ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಆಫ್ ಕರ್ನಾಟಕ ಎಕ್ಸಾಮಿನೇಷನ್ ಬೋರ್ಡ್, ಒಂದಿಷ್ಟು ಪೇಪರ್ಸನ್ನು ಆಲ್ರೆಡಿ ಬೇರೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಸಲ್ಲಿ ನೀವು ನೋಡಿದ್ದೀರಾ, ಡಿಸ್ಕಸ್ ಕೂಡ ಮಾಡಿರ್ತಾರೆ. ಇನ್ನೂ ಒಂದು ಮಾಡೆಲ್ ಪೇಪರನ್ನು ಇವತ್ತು ನಾವು ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗಲಿ ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ನನ್ನ ಹೆಸರು ವಿನಯ್, ಸೆಕ್ರೆಟರಿ ಕಮ್ ಫಿಸಿಕ್ಸ್ ಲೆಕ್ಚರರ್, ಸೈನ್ಸ್ ಅಕಾಡೆಮಿ ಪಿ ಯು ಕಾಲೇಜ್, ದಾವಣಗೆರೆ. ಸೊ ಕ್ವಶನ್ ಪೇಪರ್ ಡಿಸ್ಕಷನ್ಗೆ ಹೋಗೋಣವಾಗಾದರೆ, in the first question, statement 1, the electric field lines never cross each other. Correct alva? Because they always start from positive, they ends in negative. They never cross each other. Two field lines never cross each other. ಒಂದಕ್ಕೊಂದು ಈ ರೀತಿ ಯಾವತ್ತೂ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋದಿಲ್ಲ. If electric field lines cross each other, in case cross ಆದರೆ, the field at the point of intersection will not have a unique direction, which is not possible, because for a electric field line you can draw only single tangent at a point, which gives only one direction, unique direction. So both the statements are correct, and 2 is the correct explanation of the first statement. So that is option 1. Option 1 is the correct answer for the first MCQ. Next, the second question, the electric potential at the surface, electric potential at the surface of a charged sphere, spherical shell of radius 10 centimeter is 20 volt. So consider one spherical shell of radius 10 centimeter. On the surface of this shell, the electric potential is 20 volt. So what is the electric potential at the center hagadre? Obviously it must also 20 volts, because if this is point A, if this is point O, potential on the surface is equal to potential inside the spherical shell. Correct? So that is option C, 20 volts. Next, third question. In the equation AB is equal to C, A is the current density, C is the electric field, then what is B? It's a very simple question. AB is equal to C. What is A here? J. What is C here? Electric field. ಹಾಗಾದರೆ B ಏನಾಗಿರುತ್ತೆ? You know that current density J is equal to sigma into E. Sigma is nothing but 1 by rho, resistivity. Okay, so cross multiply ಮಾಡಿ, J into rho is equal to E. What is J? A. What is E? C. Then what is rho? It must be B, resistivity. So resistivity, option A is the right answer. Okay, so next, question number 4. If a current I is flowing in a straight wire parallel to x-axis and magnetic field is there along the y-axis, then, so current flowing in a conductor, ILB sin theta, I into L cross B. So current is in x-axis, magnetic field is in y-axis, then obviously it must experience a force in the z direction. The wire experiences force in the z direction. Okay, so next, if the magnetic susceptibility of a material is 100, its relative permeability, okay, relative permeability is given by 1 plus zeta, where zeta is called magnetic susceptibility, so which is equal to 1 plus 100, 101. So 101 is the right answer, option C. Correct? Next, needles N1, N2, N3 are made of a ferromagnetic, paramagnetic and diamagnetic substances respectively. A magnet when brought close to them will, it's a very simple question that already you know. Ferromagnetic strongly attracted, paramagnetic weakly attracted, diamagnetic weakly repelled. So that is attract N1 strongly, no. Attract N1 and N2 strongly, no. Attract N1 strongly, N2 weakly, and repel N3 weakly. So this is option C. Option C is the right answer. Next. For a transformer, Ns divided by Np is equal to 100. The number of turns in the secondary divided by number of turns in the primary is 100. What is this? Means that ಇಲ್ಲಿ current ಕೊಟ್ಟಿದ್ದಾನೆ. So you should observe the relation between number of turns and current. They are inversely proportional. So Ns by Np is equal to what? Ip divided by Is, which is equal to 100. Therefore Ip is equal to 100 times the Is. I mean primary current is 100 times the secondary current, athwa input current is 100 times the output current. The input current is 100 times the output current. So option D is the right answer. So next, statement 1, a very simple electromagnetic waves ಇಂದ ನಮಗೆ ಕೇಳಿರ್ತಕ್ಕಂಥ ಕ್ವಶನ್. The microwaves are used in microwave ovens, correct? The frequency of microwaves are matched with the resonant frequency of water molecules. That is also correct, and that is the correct explanation of the statement 1. Statement 1 and 2 both are correct, and statement 2 is the correct explanation of statement 1. So that is option A is the right answer. Next. The principle of optical fiber, you all know that optical fiber works on the principle of total internal reflection, TIR. Next, which of the following phenomenon confirms the transverse nature of light waves polarization? The first experiment in the topic, polarization confirms the transverse nature of light. So option A is the right answer. The slope of stopping potential versus frequency in Einstein's photoelectric equation is, if you plot a slope for frequency versus stopping potential, if you plot a slope for this will gives you h by E. For stopping potential versus frequency, it is h by E. If it is kinetic energy versus frequency, simply h, Planck's constant. Got it? So which one is the right answer? H by E is the correct answer. Next, question number 12. According to Louis de Broglie, waves associated with orbital electrons are de Broglie's hypothesis. They are stationary waves. Standing waves, stationary waves or standing waves. So that is option 2 or option B is the right answer. Next, it's a very simple and direct question again. When an electron in hydrogen atom revolves in a stationary orbit, electrons revolves without emitting energy, without radiating energy, but its velocity may changes. So it revolves around the stationary orbit without emitting any energy, whereas its velocity may changes. So that is option A, does not radiate energy, through its velocity changes. Next, energy generation in stars is mainly due to obviously thermonuclear fusion reaction. What is nuclear fusion? Two or more lighter nuclei fuse together to form a heavier nuclei. So fusion of lighter nuclei, that is the correct answer, option C, fusion of lighter nuclei. So next question, the electrical conductivity of pure germanium can be increased by. Pure germanium conductivity can be increased by increasing the temperature, correct? If you add acceptor impurity means trivalent. If you add a trivalent, then it will become what? P type, and conductivity increases. If you add donor impurity, then it will becomes what? N type semiconductor. Again its conductivity will increases. So all the above are correct. ಓಕೆ ನೋಡಿ, ಎಲ್ಲೋ ಒಂದು 3-4 ಕ್ವಶನ್ಸ್ ಸ್ವಲ್ಪ ಹೈಯರ್ ಲೆವೆಲ್ ಇರ್ಬೋದು. ಇನ್ ರಿಮೈನಿಂಗ್ ಆಲ್ ದ MCQs ಡೆಫಿನೆಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಅಟೆಂಡ್, ನೋ ವರೀಸ್. ನೆಕ್ಸ್ಟ್, ಲೆಟ್ ವಿ ಸಿ, fill in the blanks which you can answer directly. The first one, In some materials, the magnetization persists even after the external field is removed. Such materials are called hard ferromagnetic materials. Hard ferromagnetic materials. This is the right answer. If the current through a coil increases, its self-inductance remains the same, does not depend. So it remains the same. The phase difference between voltage and current in case of AC through pure resistor. In a pure resistor, voltage and current are in phase with each other. There is no phase difference. 0. It is 0. That is 18. The modification in the distribution of light intensity due to superposition of two or more light waves is called interference. It's a definition of interference. The Maxwell's equation of electromagnetism established the dash nature of light, electromagnetic wave theory. It is wave nature of light. Wave nature of light. So, tumba simple ide alva namige. Okay. Now, directly I will move towards the problem section because 2 mark, 3 mark, 5 mark choice irutte and easily you can answer regular important questions anna work madidre saku. Now, we shall move towards the problem section. Question number 42. Question number 42. Charges plus 2 nanocoulomb, 4 nanocoulomb, 8 nanocoulomb are placed at the corners A, B, C respectively of a square of side 0.2 meter. Calculate the work done to transfer a charge of plus 2 nanocoulomb from corner D to the square, center of the square. Okay. Now, consider a square. This is A, B, C, D. Okay. Now, let me consider the center of this square is O. This is 0.2 meter. This is 0.2 meter. Now, first you have to find the OA, OB, OC distance. I mean, in a triangle ABC, right angle triangle, AC square is equal to AB square plus BC square. That is 0.2 square plus 0.2 square, 0.04, 0.04, 0.08. Hence, AC is equal to root 0.08. It will become 0.2828. Hence, OA equals OB equals OC, which is equal to OD 0.1414. Okay, first ಇದನ್ನು find out ಮಾಡ್ಕೋಬೇಕು. Anyhow, you have calculator. Now, you have to find potential difference. This is the main formula. Work done is nothing but charge moved into potential difference. That is potential at O due to ABC charges, potential at D due to these 3 charges. Okay, so potential at O is 1 by 4 pi epsilon naught into charge at A divided by OA plus charge at B divided by OB plus charge at C divided by OC. Hence, potential at O is 9 into 10 to the power 9 nanocoulomb. ಎಲ್ಲದರಲ್ಲೂ ಕಾಮನ್ ಇದೆ, ತೆಗೆಯೋಣ. OA, OB, OC are common. 0.1414. This is 2 plus 4 plus 8. ಇಲ್ಲಿ 2 nano, ಇಲ್ಲಿ 4 nano, ಇಲ್ಲಿ 8 nano. All are positive. Okay, you should consider the sign in this chapter. All are positive. 2 plus 4 plus 8, 14. Plus 9 minus 9 get cancelled. So, if you simplify this one, nearly you will get 891 volts. Anyhow, ನೀವು ಆಮೇಲೆ ಕರೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಿಯರ್ಲಿ ಯು ವಿಲ್ ಗೆಟ್ ಆಲ್ಮೋಸ್ಟ್ 891.08 ಬರುತ್ತೆ, 891 volts. Similarly, potential at D 1 by 4 pi epsilon naught into charge at A divided by AD distance, charge at B divided by BD plus charge at C divided by CD. If you simplify this one, 9 into 10 to the power 9, taking nano common, 2 divided by 0.2 plus 4 divided by BD 0.2828 plus 2 divided by this is 8 nanocoulomb, 8 divided by 0.2. If you simplify this one, plus 9 minus 10 cancel, 0.2 tens, 0.2 40s, ಇದು 4 divided by 0.2 ನಿಯರ್ಲಿ 14 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನು ನೀವು 9 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರಿ ಅಂತ ಅಂದರೆ ಯು ವಿಲ್ ಗೆಟ್ ನಿಯರ್ಲಿ 578.5. 578.5. Now work done is charge moved into potential at O minus potential at D. If you simplify this one, you will get the final answer. Charge 2 nanocoulomb. 2 into 10 raised to minus 9 into 891 minus 578.5. So again, if you subtract 578.5 from 891 and you will get the final answer is nearly 625 into 10 raised to minus 9 joules. If you subtract and multiply it by 2, so this will be your final answer, 625 into 10 raised to minus 9 joules. Okay, you can take the screenshot if you want. Over? Yes. Now we shall move towards the next problem. A wire having length 2 meter, diameter 1 millimeter and resistivity 1.963 into 10 raised to minus 8 ohm meter. Let me show clearly. Yes, is connected in series with a battery of EMF 3 volt and internal resistance 1 ohm. Calculate the resistance ಕಂಡುಹಿಡಿಬೇಕು and current ಅನ್ನು ಕಂಡುಹಿಡಿಬೇಕು. ಓಕೆ ಫೈನ್. ಡಯಾಮೀಟರ್ 1 millimeter ಇದೆ ಅಂತ ಅಂದರೆ ರೇಡಿಯಸ್ 0.5 millimeter ಆಯಿತು. ಓಕೆ, ಇನ್ ದ ಫಸ್ಟ್ ಕೇಸ್ ಟು ಫೈಂಡ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್, R is equal to rho into L divided by A. As area is not given, radius is given, so area of a wire, area of cross section pi r square. Hence R is equal to what is the value, 1.963 into 10 raised to minus 8, length 2 meter divided by 3.14. what is the radius? 0.5 millimeter, 0.5 milli, 10 raised to minus 3 whole square. If you simplify this one, you will get 0.05 ohms. Okay, if you simplify this one, you will get 0.05 ohm, that is resistance. Second case, to find the current in the circuit. When EMF is given, Ohm's law applied to the whole circuit formula, I is equal to E divided by R plus R. Hence, I is equal to 3 divided by what is external resistance here, 0.05 plus internal resistance is 1 ohm, which is equal to 3 divided by 1.05. Hence, if you simplify this one, you will get 2.85 amperes. Hence, your final answer is current 2.85 amperes, resistance 0.05 ohm. Again, if you want, you can take a screenshot. Over. Next. A sinusoidal voltage alternating current ಮೇಲೆ ಬಂದಿರತಕ್ಕಂಥ ಪ್ರಾಬ್ಲಮ್ of 250 volts and frequency 50 hertz is applied to a series LCR circuit in which R is equal to 6 ohm, 25 millihenry, capacitance 796. Impedance and power factor. Impedance ಅಂದರೆ XL, XC ಬೇಕು. First find XL, XC, then substitute those values in the impedance formula and finally find power factor. To find impedance is Z. Before that, find XL. What is XL formula? 2 pi FL. Omega L, omega andre 2 pi F. 2 pi FL. 2 into 3.14 into 50. What is L? 25 milli. If you substitute all the values and find the value of XL, you will get 7.85 ohms. 7.85 ohms. Calculator allow irutte, hegidru simple calculator, you can find XC 1 divided by 2 pi FC formula, 1 divided by 2 into 3.14 into 50 into 796 micro minus 6 ಮೇಲ್ಗಡೆ ಕಳಿಸ್ರಿ plus 6 ಆಗುತ್ತೆ. So if you simplify this one, nearly you will get 4 ohms. XC is nearly 4 ohms. Now what is the formula for impedance? Z is equal to square root of R square plus XL minus XC whole square. So if you substitute the value of R 6 square plus XL 7.85 minus XC 4 whole square. So if you subtract 4 from 7.85 and find the square value, 6 square is 36. If you add, you will get 7.128 ohms, nearly 7.128 ohms. B. To find the power factor is nothing but cos phi. So what is power factor? The ratio of resistance to the impedance, R by Z. Power factor is 6 divided by 7.128. So 6 divided by 7.128, 0.841, which has no unit, because R igu ohmu, Z igu ohmu, no unit. Cos phi is equal to 0.841. This is your final answer. Again, a very simple problem. If you want, you can take a screenshot. Next, last problem, dual nature of matter and radiation bandide ee model paper alli. Light of frequency 8.41 into 10 raised to 14 hertz is incident on a metal surface. Electrons with their maximum speed of 7.5 into 10 raised to plus 5 meter per second are ejected from the surface. Calculate the threshold frequency nu naught for the emission of electron. Also find the work function in electron volt. So you should find the threshold frequency nu naught first, and after that find the work function phi naught in electron volt. Whatever the problem asked in this chapter, it's very simple actually. Einstein's photoelectric equation, okay, to find, first I will use to find the threshold frequency. Einstein's photoelectric equation, kinetic energy is equal to E minus phi naught, velocity ಕೊಟ್ಟಿರೋದ್ರಿಂದ half m e square, stopping potential ಕೊಟ್ರೆ E v naught, frequency ಇರೋದ್ರಿಂದ h nu, work function h nu naught, taking h common, nu minus nu naught, h cross multiply, mv square by 2h is equal to nu minus nu naught. You want to find nu naught, threshold frequency. Therefore, nu naught equals nu minus mv square divided by 2h. Hence, nu naught is equal to, what is nu? 8.41 into 10 to the power 14 minus mass 9.1 into 10 raised to minus 31, velocity 7.5 into 10 raised to 5 whole square divided by 2 into 6.625 into 10 raised to minus 34. If you simplify 8.41 into 10 to the power 14, it is nearly 38 point something into 10 to the power 13 baratte. But you can't subtract, because to add or to subtract 10 to the power powers must be same. Either ಎರಡನ್ನು 14 ಮಾಡ್ಕೋಬೇಕಿಲ್ಲ 13 ಮಾಡ್ಕೋಬೇಕು, ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಓಕೆ, ದಟ್ಸ್ ಅ ಬೇಸಿಕ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. ಸೊ ಇಲ್ಲಿ 3.8 into 10 to the power 14 ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಅದನ್ನು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದರೆ ಯು ವಿಲ್ ಗೆಟ್ ನಿಯರ್ಲಿ 4.547 into 10 to the power 14 hertz. So this is your final answer for threshold frequency. Now second part is to find work function phi naught. To find the work function phi naught, what is the formula for work function? H nu naught. So very simple. ಇದನ್ನು ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಲ್ವಾ, ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ಜೌಲ್ಸ್. ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಜಸ್ಟ್ ಡಿವೈಡೆಡ್ ಬೈ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಚಾರ್ಜ್ E, then it will be in electron volt. Hence phi naught is equal to 6.625 into 10 raised to minus 34. What is nu naught? 4.547 into 10 to the power 14 divided by 1.6 into 10 raised to minus 19, because you should put work function in electron volt. That's why divided by the charge of electron. If you simplify, you will get nearly 1.882 electron volt. So this is your final answer. So dear students, if you work on these type of model papers, at least you can solve you solve minimum 10 to 20 model papers. Definitely your marks will be more than 55 or 60 plus out of 70. All the best.